You're back.
Yes, we are.
Are you excited?
No.
Put your answers.
My group did pretty good.
What was that?
I think my group did pretty well.
Pretty well. Okay. I get to determine it.
Okay.
Okay, so this is what we'll do. Let's see.
I don't remember the group name though, like group 1, 2, or 3 or whatever, or the breakout.
Don't worry. I'll let you know.
Okay.
Let's see. Come on. Fix this real quick. Okay, so we'll have one would be Iberi, still winning, Jenny, Mary, Miguel. 2 would be Rocky, Eric, Erica, Kelsey. 3 would be Anna, Fabian, Jonathan, Vanessa. 4 would be Alexandria, Matt, Megan, and Raina. 5 would be Angeline, Priscilla, Elizabeth, and Heidi. And then we'll repeat.
But I'm group 2, right?
What's it called? Do you want me to write it?
Yes, Kelsey.
Matt and Megan? Okay, I'll just do it.
What's a subscript, just so you know?
Yes.
For group 3, does somebody want to write it? I have horrible writing on this thing. Thank you, Fabian, I think it is.
Zirconium. Wait. 1, 2, 3, 4, 5.
My handwriting sucks.
Oh, I didn't get this one. Wait.
Let me do it again.
Somebody just double check group 2 because I don't want to get them wrong, and I wasn't 100% sure on this.
I didn't get 7. I didn't get the second.
I know, but like if somebody else wants to help that does have this one and they see it wrong, because I don't want to get it wrong and then screw everybody else up.
Mm-hmm.
So just double check group 2's if you guys get a chance. That's what I got for both of those. And then HiO4. I got HiO4, that is PeRiO. Dang, Eric, just make me carry the group, you know.
I honestly didn't even get the last one from that one, from the word. And then I didn't even get to that one either. I was just like, damn.
Barry, check my work.
Which one are you?
The last one looks right though.
Well, yeah, but zirconium 2 phosphate. I know anhydrous is no water, but that one screwed me up. No agua.
For me, I wrote ZR, then parentheses sulfates, SO4, then 2 for the last one. Did you hear me?
Yeah, I heard you. For the zirconium?
Yes, zirconium.
Who did number 1?
Me might be wrong though. I'm not sure.
I don't think there's a
Can I
2.
do ours for number 4? Because our group got number 4 and 4 for the other side too.
Let me
I
see.
don't think there's a 2 after the PD because it should be or P.
It should that
Only
one
and then also have a
PD
subscription.
for number 1. It should be PD CR05 and then a 2.
Yeah, CR. Why would it be CR05?
Because it's hypo.
Mm-hmm.
So
But
you
didn't have 7.
So the CRO, because it would be 6 for 8, and IT turns to 6, and then hypo turns to 5.
Okay, but I thought.
Because dichromate is CR207,
Yeah.
dichromite is CR206. So if you have hypodichromite, you take away another oxygen, which makes it CR205.
Yeah.
Right there. Yeah.
So, are you guys happy with your answers?
Radium oxalate,
Wait a minute. I'm trying to go to see if my answers match theirs.
mercury nitride, nitride. I got dinitrogen for that one, but I don't know if that's right. Nitride.
I think 3 is correct. I think I something like that.
For number 3, I got mercury VI dinitride.
That's what I got. Mercury VI dinitride.
Yeah, that's what I got too. Because I got the dinitride because there's 2 nitrogen.
Yeah, same.
Yeah.
And the VI because there's 6.
So
Wait, hold on. What is the rule? What is mercury?
I rejected LX. I rejected mercury 1 nitride.
Oh, it's the damn
Yeah.
exception. You're right.
Mercury 1 is Hg2 plus, and the nitride is 3 negative.
Are you guys 100% sure with your answers?
And you can give us a minute, Dr. Henry?
I can.
So it's not dinitride, it's just nitride.
Yeah, mercury 1 nitride.
Okay.
Yeah.
HiO4 with the parentheses G, don't you have to write it out?
Which one?
I did. Periodic acid. It's underneath it.
I know, but don't you have to put like,
Periodic acid.
hold on, I can't find my paper.
So I have for the gas HiO4G, I actually have hydrogen periodate.
It's per iode.
Iodic would be for number 2, because that AQ means acid. That's why you have the ic. So acids are only when you change the ending. So that's why for the one above it with the gas, it shouldn't be ic, it should be iodate. And we had hydrogen per iodate because iodate is IO3, and since it's 4, it'd be per. So it's per iodate, and then you have the hydrogen. So hydrogen per iodate.
But I think it's different because it's a covalent compound, so I think you have to write them all out. Like I got hydrogen, iodine, tetroxide.
For gas or for acid, you got that.
For the gas.
Oh.
But the IO4 is part of the polyatomic ion.
Yeah.
Oh, wait. Polyatomic ion. Ooh, hint. So covalent versus polyatomic ion.
So then that's probably what it should be. I didn't do that one. That one, I'm not group number 1, but that makes sense. Do you want me to change it? It's not my group, but I don't mind. I don't want to open this test tonight.
The only ones I'm unsure on are 10 and mainly 11.
Can I write it like this? Can I write or? Just kidding.
No or. You got to be confident. So you guys are saying, what did you say, Elizabeth?
I said that it's hydrogen, iodine, tetroxide without the A, just tetroxide.
I was thinking about that. I think I had mentioned, but we had George, and George said that. I thought that's what it was too.
Gases screw me up, man.
Yeah, gases, me too.
Okay, you guys ready?
Ready or not.
Okay.
Yes.
So the first one, the first green one, that is correct. The second green one, that is correct. The third green one, silver oxide, is correct. Tungsten thiocyanate is correct. Magnesium astatite is correct. Cobalt. Okay, I have a question about this. Is this a lowercase o Iberi?
Uppercase.
Uppercase.
That's an uppercase. Then make it look like an uppercase.
Dr. Henry, you can't go judging people's handwriting on this.
I can tell if it's an uppercase or a lowercase. I just can't tell what it is.
We know we all know sulfite is S uppercase and O also uppercase.
Okay.
Look at him. He's trying to make money right now.
I am. $1 million. Okay, so that is correct. Zirconium-2 phosphate
Kelsey.
anhydride. Good job, good job. Okay, mercury-1 nitride is correct.
One fucked me up.
Ammonium silicate is correct. Radium oxalate is correct. Hydrogen iodine tetraoxide is correct.
Good job, Elizabeth.
And peridoic acid is correct.
That's right.
Yeah.
Good job. Good
Good
job.
job, T.
You lost.
I thought I was going to win because I would start seeing those ones that were going kind of crazy there. And I'm like, okay, that's going to be a freebie. I'm going to add some really hard ones on there now.
Got it.
What was that?
Teamwork makes the dream work, and we got it.
Yeah. You guys checked each other. You see how that works, right? You see how that works?
Well, it's kind of hard when we're at home doing this, you know.
So just let us take it together, like in the groups. Like,
Does somebody mind trying to explain those last two?
Sure.
Dr. Henry.
Sure. Somebody can explain it. Go ahead. I'm listening.
Dr.
I want to
Henry,
hear.
how to do it.
You're good at explaining.
Who's going to explain?
How about George?
Or
Yeah.
whoever wrote the answer down, because she sounded like she knew what she was talking about. So,
Elizabeth?
yeah.
Are you there, Elizabeth?
Yeah.
You want to explain it?
I mean, I can try.
That's all I can ask.
Hold on, I gotta find my cheat sheet though to explain. So the gas is a covalent bond, right?
Yep.
So you have to use, like, you can't use the polyatomic ion sheet because it's not an ion. So you have to write each one out: hydrogen, iodine, and then tetraoxide because there's 4 oxygen, and then the last one always ends in "ide." And then What?
Periodic acid.
So that you use the IA organic apples despite them being poisonous. And since there's an O and an H, use that one instead of the myride has hydro. So it'd be periodic because the IO4. Is that you use your polyatomic ion sheet? And iodate is IO3. And then since it's per IO4, you have to go up one, so it would make it per iodate. And then since it ends in 8, it becomes ic, periodic acid.
That is correct. So to put it briefly, you have this H and you have AQ. As soon as you see H and AQ together, your first thing should be thinking acid. If you see H and gas together, then the first thing that you should be thinking is covalent, right?
And when we determine that we're talking about the covalent bond, we know that we're not going to the polyatomic table for names.
That's right, because they're not ions, right? Polyatomic ion table. It's called an ion table because it's an ion. If it's a covalent bond, is it going to be an ion?
No.
If everything there is covalently linked.
Okay.
Okay. So that's kind of like a hint. Although the
Spell it out.
What was that?
It was a gas. You spell it out, or you write it out.
Yep. And with the Greek prefixes.
Right.
The only thing that you should be using Greek prefix for are your gases or like covalently bonded material. So if it says covalently bonded, you should know immediately you're going to be using Greek prefixes. And you only use it Greek prefix for your hydrates, right? Octahydrate.
What was that again, Dr. Henry? I'm sorry.
You only use Greek prefixes for covalent bonds, covalently bonded material, and your hydrates. Are you good?
We're good.
Piece of cake?
Piece of cake.
Good, good.
Big, but like you said, teamwork makes everything work.
Well, you use teamwork to study, right? Teamwork to study. Then on the test, you show your own talent, right? You show your glow.
We should take the test together.
Okay. Okay, so I have something to go over real quick, and then we need to we need to keep going. So let me.
We're gonna go longer than today?
I mean,
Okay, I have a question. 1 dozen. A dozen equal what?
12.
12.
So if I have a dozen of donuts, how many donuts do I have?
12 donuts.
12 donuts.
If I have a dozen girlfriends, how many girlfriends do I have?
12 girlfriends.
If I have a dozen boyfriends, how many boyfriends do I have?
No problem.
I have a lot of problems. That is true. Okay, so we know that a dozen is 12. Is that correct?
Yes.
which
Okay. Pretty simple. You always know when we talk about a dozen, it's always going to be 12. Right? So a mole is 6.022 times 10 to the 23rd.
What chapter is this?
We should be in 7.
Yep.
7? Okay.
Yeah. Slide 9, I think.
that says 1 mole.
1 mole.
There's no E?
Well, that's the abbreviation for it.
Okay.
It's NE, but we use 1 MOL
Okay.
or yeah. So
Times 10 to the 23rd.
yep, times 10 to the 23rd, right?
Yeah. Oh.
So if I have a mole of donuts, how many donuts do I have?
If you have what?
A mole of donuts.
10 to the third.
Okay. If I have a mole of girlfriends, how many girlfriends do I have?
6.022 times 10 to the 23rd girlfriends.
If I have a mole of problems, how many problems do I have?
The same amount of girlfriends that you have.
Times 10 to the 23rd.
Same number of girlfriends, right? Exactly. You got it. Okay. So we know that a mole is always going to be 6.022 times 10 to the 23rd, right? So this here is Avogadro's number, which we've talked about before.
Oh, what's number?
Whose number?
Avogadro's.
Avocado.
Avocados?
Avocado?
I can spell it.
That's how I remember it.
Avogadro's number.
I'm gonna have to use that whenever this is on the test. Avocado number.
So this is Avogadro's number. So that basically we know that a mole is always going to pertain to 6.022 times 10 to the 23rd, always. Okay. So that is a guarantee, right? Okay. So what was that?
Is this a 4 or is that an arrow or a
Where? Oh, that's an arrow.
Oh,
Bracket?
122?
6.022 times 10 to the 23rd.
Oh, okay.
Okay, that's Avogadro's number. You guys, you should know that. You should already know that. You should already have that tattooed on your chest. I think we talked about that a few chapters ago, right?
No, I don't remember it.
Well, now we did, so. Okay. So we know that for sure, right? We're feeling pretty confident in that. So that tells us the number of, in the case we could be talking about molecules, we could be talking about atoms, we could be talking about girlfriends, we could be talking about socks, we could be talking about pennies, right? We know that it could be anything, right? Just like a dozen. A dozen could pertain to anything. Donuts, husbands, wives, problems, you know?
Cheetos.
Okay. Crazy students that text you at 2 o'clock in the morning.
Angry teachers.
They all dropped.
They all dropped.
Real big problem if it was 2 in the morning.
What was that?
If it was 2 in the morning, it must have been a real big problem.
Yeah.
Were you soft off the cranberry juice?
What was that? It was soda, cranberry soda. It's not cranberry juice.
Oh, your cranberry soda. Were you sauced off that
Right.
at 2 in the morning when they called you?
Okay. So, and you guys are feeling comfortable with that. You guys recognize that that's what it's going to be, right? And so we know that we could be talking about a mole of atoms, right? So we know that that means that we have 6.022 times 10 to the 23rd atoms, right? We could be talking about a mole of molecules like oxygen gas, right? So that's 6.022 times 10 to the 23rd oxygen gas molecules, right? Or it could be like a mole of an ionic compound, right? Like sodium chloride. So that's when we're talking about like quantity. So we know that's how many that we have, right? Quantity. So like, for instance, if I talk about a mole of apples and a mole of grapes, are they going to weigh the same?
Yes.
Yes.
A mole of apples and a mole of grapes are going to weigh the same?
Yeah.
Yeah.
I mean, they're moles. If
Yeah.
they're
Like them.
Are you sure?
Yeah,
It's all the
when
same.
it's 6.022 times 10 raised to 33.
You said
Okay,
that's all
now
the same.
listen to what I'm asking you.
An
right?
apple
And
and
I want you to think about it. How
No,
big is an
because
apple?
now you're talking about mass,
Wait.
not
Hey,
quantity.
Exactly, because now I'm talking about mass. I'm not talking about quantity, right? So how much does a grape weigh, right? Grape is only this big. An apple is this big. who's going to weigh more?
Apple.
So if I have
Yeah.
6.022 times 10 to the 23rd apples, and I weighed them, and I have 6.022 times 10 to the 23rd grapes, and weighed them, who's going to weigh more?
The apple.
Apple.
The apple, right? So the difference, we want to make sure that we understand the difference between when we're talking about moles as in quantity and we talk about mass, okay?
So moles can be quantity and mass?
Wait, we'll get there. They can't be both, right? So moles is just quantity, but we can use moles to compare mass, right? And the way that we do that is by molar mass. And so that kind of brings us up to our topic today. Every time I feel like I'm on one of those Zoom commercials, I mean, one of those commercials about Zoom.
Hi.
You a mess today.
I am tired. I had a long weekend. I would love to say it was because I was turning up, but hell no, I wish I was.
Sorry to hear that.
Okay, sodium nitrate is, how many sodium atoms do we have?
One.
One, right? So we have one sodium atom. How many nitrogen atoms do we have?
One.
So we have one nitrogen atom. How many oxygen atoms do we have?
Three.
Okay, so that there is going to be the breakdown of the formula, right? So we know that for one molecule of sodium nitrate, we have one sodium atom, we have one nitrogen atom, and we have 3 oxygen atoms. Okay, so this is where we start using a periodic table to determine its mass, right? And what we call molar mass. Molar mass is in the units of grams per mole.
Grams per mole.
Per mole, right? So your periodic table, when we talk about its atomic mass, what is the atomic mass of sodium?
22.990.
22.990, or we could round easily to 23, right? What about nitrogen?
14.007.
And oxygen?
12.001. Nope, was
So
wrong.
oxygen?
16.
15.999.
999
Okay, 15.999.
times 3.
And there's 3 of them, right?
Yeah.
Yeah.
Okay. So for the atomic mass, or the molar mass of the compound, it's going to be the sum of all of them together.
Do we round them? Can we round them or?
You can round them, yeah. So if we're talking about one molecule, right, we would say atomic mass units or mass units, right? AMU or MU, right? Atomic mass unit. So this guy would have 85 atomic mass units.
And that's what you got after you added it all up.
Yep. You better check it because, you know, like I said, long
That's
weekend.
I got it because I didn't round. It was 84.994.
Okay.
Yeah, I rounded them.
So, but we can scale up, right? And so when we scale up, we can also use this 85 to represent our atomic, our molar mass. Yep, which is grams per mole. Molar mass. So when we think about molar mass, it's grams per mole. Mass, which we always put in grams, per mole, molar mass. This is called formula weight.
The AMU?
AMU, yeah. So, but that's talking about one formula unit, right? So one formula for that one compound, that's it, for if you have one, okay? But it's scalable. Okay, are you with me?
It's 6:30.
I know.
So, Dr. Harry.
Yep.
What's the difference now between the formula weight and the molar mass?
So formula weight, basically,
the unit.
It's the units. Other than the units, so formula mass is based upon that single unit.
Okay.
It's talking about one. It's talking about one molecule of sodium nitrate.
Sodium nitrate. Okay.
Where molar mass is talking about the weight per mole, which is a whole bunch, right? What is 1 mole is equal to what again?
6.022 times 10 to the 23rd.
So it would be 6.022 times 10 to the 23rd molecules of sodium nitrate.
That makes sense. I don't understand. I don't understand. I like Abiri's question, but I don't understand your answer.
Okay. 1 mole equals, you said, 6.022 times 10 to the 23rd?
Yep.
We're supposed to make
In this case,
rice
molecules.
and spaghetti. But Daddy likes black beans, so we have to cook black beans.
Of sodium nitrate. Okay, so I'm saying that if we weighed all of those molecules together, this would be the weight that you got. That's how much it weighs. So 1 mole is going to be 85 grams.
It's kind of like adding all their weight.
Exactly, exactly. And so we use that because if you think about it, can you guys see? Can any of you guys? I mean, if you have really good eyes, if you have got eyes this good, let me know because we're going to use you for some other things. Okay, can you see 1 molecule of sodium nitrate? No, you can't, right? So for us to be able to touch it and to feel it and to use it, we're going to have to use a whole bunch of molecules, right? And so that's why we choose to use the mole, because it allows us to get a grasp on it in a sense, right? Otherwise, we'll be working with a single molecule. Did you try to do an experiment? Hey, let's see if we can move this 1 molecule and this 1 molecule. What's the purpose, right? It's not enough for us to do anything with. Okay, so we have to scale up in a sense. And by using the mole, by using a whole bunch of quantity of it, we're able to scale up. Are you with me now?
So that's formula weight.
So formula weight is for the atomic mass unit. That's talking about a single molecule, right? So that's looking at a single molecule, and this is scaling up to a whole bunch of them, right?
So single molecule for formula weight, and then
That's right.
Collectively is the mass, molar mass.
That's right.
Say that again. Formula weight equals single
molecule.
Thank you. And then molar mass is air body.
Yep.
Okay.
Okay. Okay. So to calculate our molar mass, we just use our periodic table, right? So if we were calculating the molar mass of sodium chloride, NaCl, what would be the molar mass of that guy?
22.99 plus 35.45.
So NaCl, 1 sodium, 1 chloride. You said
35.45.
Something like that, right?
58.
So that's what, 58. 0.45.
50?
Yeah.
Totally judging.
8.44.
Yeah, before you quit because we don't want it to.
Okay, that's grams per mole, right? If we're talking about molar mass. If we're talking about AMU, it'd be 58.44 AMU.
And that's for the formula weight, right?
That is correct.
When would you write out AMU?
When you're talking about like a single atom or a single molecule of things.
Okay.
So this is talking about one molecule, not a mole. Molecule and a mole are not the same thing. A molecule is just our sodium chloride, right? And then molar mass is a whole bunch of them. It's 6.022 times 10 to the 23rd molecules.
It would be like 22.99 AMU plus 35.45 AMU equals that. That's how you would say it?
Yeah, so it would be, you'd add them together and then it's just AMU, right? So it's scalable, right?
Yeah.
So do you guys understand it? So we could talk about a single molecule, or we could talk about a whole bunch of them.
Yes.
And it's the same, essentially the same mass, right? But different units.
So what does that have to do with the 6.022 times 10 to the 23rd? If you're saying—
Because we know that a mole is that many molecules, right? So if somebody gave you, okay, so you only have 50 molecules to work with, could you calculate the mass of 50 molecules? So if I have 50 molecules, 50 molecules.
Molecules of what?
Of, let's say, sodium chloride. Could you calculate the mass of that?
Yes.
How would I do that?
What you just did.
Find the mass, and then why wouldn't you multiply it by the amount of molecules you have?
Yeah, you multiply by 6.02.
Would I multiply by?
Oh wait, I'm not doing it right.
You're gonna divide it.
Okay, I would divide it by 6.022.
1 mole on top.
Times 10 to the 23rd molecules.
Oh, I don't like this.
Bye.
That still counts as red.
And that's 1 mole.
Okay, that's not too bad.
What do you mean that's not too bad?
Let's try
Okay, so then that would give me my number of moles, and then I can multiply by the mass. So I have 1 mole, because I want my moles to cancel out, over 58.45 grams. Sorry, 44. My bad.
And that's how you figure that out.
So if I have molecules, I can use Avogadro's number to convert to a number of moles. And then I can use the molar mass to calculate how much those molecules weigh. You see that?
Yeah.
Okay. Okay, so this is our stopping point. We're a little bit over.